In this video, we're going to be talking about many useful factorizations in Algebra 1 problems and in Algebra 2 problems. So let's get started. So we're going to go ahead and start. So the first factorization we have is, or a useful technique in Algebra 1 problems or Algebra 2 problems is rationalizing the denominator. So let's say I have 1 over root 3 or square root of 3. Now, whenever we're faced with a problem where we have the denominator is a radical, we can easily take this radical and we can take it to the top, to the numerator, to get rid of it in the denominator. This will make it easier to solve the problem. So to do this, we need to think of a number that when multiplied to root 3, any number n, when multiplied to root 3, will produce an integer. Now, when any number, let's say the number is n, it needs to produce an integer. So obviously, we know that squaring a square root will get rid of the radical. So we can just multiply the numerator and the denominator by the square root of 3. We can multiply by, I'll just erase this on the bottom. So now, multiply numerator and denominator by this root 3. We have in the numerator 1 multiplied by root 3 is 1 root 3, and we divide it. Square root of 3 multiplied by square root of 3 is just 3. 1 root 3 is just root 3. So our answer is root 3 over 3. And yeah, that's how you would rationalize the denominator. We're going to take a look at another example. Now let's say we had a number, we'll do 9 over the cube root of 3. Now in this problem, we need to get rid of the cube root, and the way to get rid of a cube root is by cubing the number. So we know that 3 can't be, 3 isn't a perfect square, it is not a perfect cube. So obviously we need to multiply by something that makes a 3 cubed. We know that 3 is just equal to 3 to the 1. Now 3 to the first power multiplied by 3 squared is going to give us 3 cubed. 3 cubed. So we know that 3 cubed multiplied by 3 is just 3 cubed. 3 squared multiplied by 3 is 3 cubed. So given this in mind, we can multiply numerator and denominator by the cube root of 3 squared. And now, on top we have 9 cube root 3 squared. On bottom we have this is just a cube root of 3 cubed. Just a cube root of 3 cubed. Hold on. Multiplying. Cube root of 3 cubed. The cube root of 3 cubed is just 3. We can pull out a common factor here. 3. And now our final answer is 3 squared is 9. This is our final answer. Now we know how to rationalize the denominator. We are going to see a different type of problem. So when we rationalize the denominator, we're just strategically multiplying by something over the other, which is just equal to 1. So now we're asked to rationalize this denominator. We have 1 root 5 minus root 4. I want to have to multiply this by something. Now, given this, all we need to do here is when we have root 5 minus root 4, we need to multiply this to something that will give us an integer value. The way we can do this is by multiplying the square root of 5 by the square root of 5 and multiplying negative square root of 4 by plus square root of 4. And this factorization is known as the difference of squares factorization, which I'm going to talk about here in a second. So here we can just use difference of squares factorization if you already know this. If you don't, we're going to talk about this in a second. So over here, we just multiply top and bottom by this. This. And we're going to multiply top and bottom by this value, root 5 plus root 4 plus root 4. Over here, we have 1 multiplied by this. That's just root 5 plus root 4 over here, square root of 5 multiplied by square root of 5. That's just square root of 5 squared. Squared gets cancelled. These cancel. We have 5 minus square root of 4 multiplied by square root of 4. The squares cancel. We have 5 minus 4, which is just 1. So in reality, this is square root of 5 plus square root of 4 over 1. But yeah, so if we want to rationalize the denominator, we can use, in this form, we can use our difference of squares factorization. Now, what is the difference of squares factorization? Difference of squares factorization is useful in multiple algebra problems. It's mainly when we have a difference of 2 squares and we want to factor it. So let's say I have difference of 2 squares. I have a squared minus b squared. And I want to factor this. So the way we're going to factor this is using something called the difference of squares factorization. Difference of squares factorization is when, so basically we're going to factor this. So when we factor this, I know I'm going to have parentheses. I'm going to have an a over here, a over here. And I also, now we have a squared over here. We have a squared. We're going to have minus b squared. The way we do this is, well, we're not going to have two positive. We're not going to have a plus and a plus. We can't have a minus minus. That's going to give us a plus, and that's going to alter this. We're going to have a minus, and I'm going to pair the negative positive. I'm going to pair the negative with the positive, and then I have a b right here, and then b squared. So when we expand this, a multiplied by a plus b, it's a squared plus a squared plus ab, minus, over here, ab minus b squared. These two terms, they cancel, and we have a squared minus b squared. So for difference of squares factorization is when we take a squared minus b squared is going to be equal to a plus b, a minus b, as a product of two binomials. And now we can use difference of squares factorization to evaluate value expressions. So the way we're going to do this is we can use difference of squares factorization in a number of ways, but I'm going to show a common way. Let's say we have an expression. We're asked evaluate 8 squared minus 7 squared. Obviously, first thing that comes to mind is the difference of squares factorization. So we're going to use difference of squares factorization. We're going to factor this as a product of two binomials. Now, 8 squared minus 7 squared. We can say this is just a. So this is a squared minus b squared. And now we know difference of squares, a minus b, a plus b. Now over here, I'm going to have an 8 minus 7, 8 plus 7. Most people will think you'll just solve this. So 8 minus 7 is 1. 8 plus 7 is 15. So our answer is 15. Extremely easy to do expressions like that. Another problem we're going to see is 7 squared minus 6 squared. Again, a and b, plug our values in. 7 minus 6, 7 plus 6, 7 minus 6 is 1, 7 plus 6 is 13. Answer, 13. So that's how we can use our difference of squares factorization. That's basically 100. Now we're going to talk about another factorization, which is when we square two binomials and identifying squares of binomials. So first, we're going to expand two things. We're going to expand x plus, it's supposed to be plus, x plus 4 squared. Now immediately when we expand x plus 4 squared, it's just x plus 4. We can write this as a product of two binomials. So this, when we expand the product of two binomials, x is multiplied to everything here, so we have x plus 4 4. All I'm doing is expanding the product we have. X squared plus 4x plus 4x plus 4 times 4 is 16. X squared plus 4 plus 4, 4x plus 4x is 8x. X plus 16 is the expanded version of this. Now, if we notice a sort of clue here, the first term in our expression here is x squared. This is just this term squared. The last term is just 4 squared, this term squared. And the middle term, 8x, is just the product of the terms in the binomial, 4x times 2. So that's just 8x. So we don't need to go through this entire process every single time. We don't. It's a waste of time. Which is why when I see a product of two binomials, I don't like to do this work the entire time. We're going to try a different product here. X plus y squared. Here, x plus y squared. I take a look at this. I square x. X squared. That's the first term. Y squared. That's the last term. Now in the middle, it's going to be 2 times the product of the terms in the binomial. Product of the terms in the binomial is xy. Slap 2 times xy is 2xy. So we have xy plus y squared. So anytime you see a product in binomials, it's easily expandable using this. First term, square it. Last term, square it. The first term squared is the first term in the expanded form. The second term squared is the last term, and the product of the terms in the binomial multiplied by 2 is the middle term. Like this. Term. Second. Product. Alright, product of terms binomial times 2. And that's the basic form. Whenever you see product of two binomials, it's going to be the same thing. Now, let's try something else. Let's try something using squares of binomials. And squares of binomials is useful because we can square numbers in our head. So let's say we have 16. Many people know their squares in their head. I don't. 16 squared is not obvious to me. So what I like to do is I like to use squares of binomials factorization. 16 squared can be written as 10 plus 6. Alright, 10 plus 6. That's 16 multiplied by 16. And now immediately I notice that this is just 10, 6 squared. 10 plus 6 squared. Again, squares of binomials. 10 squared is 100. Product of the terms of the binomial is 60. 60 multiplied by 2 is 120. And then 6 squared is 36. 100 plus 120 is 220 plus 36. 220 add 36, we have 256. It's very easy to compute. Let's say we have 99 squared. That's just 100 minus 1 squared. 100 squared is that 10,000. Product of the terms 100 multiplied by 2, which is 200, and so that's 10,000. 100 product of terms is negative 100 multiplied by 2 is 200, and then 1 square is obviously just negative 1 square is 1. So we compute this. 10,000 minus 200, that's 9,800. 9,800 plus 1 is 9,801. So 99 squared is 9,801. 801. So as you can see, there are many different ways we can use these factorizations. And yeah. I will be releasing a part 2 of factorizations. And yeah, that's it for this video. Hopefully this helped.